Hello all, this is Mr. G, and this is our warm-up for today's lesson. So pause the video right here, give this problem a shot, come back when you think you have an answer. We're going over 3, 2, 1, let's go. It says determine a and k, so the given points are on the graph of the function. We've got negative 2, 6, 3, 1, and they give us part of the function rule, part of the equation here. We've just got to find a and k to complete it. Well, hopefully remember from the last video, a big skill we talked about was anytime we have an ordered pair, that's an x and y we can plug into our function rule, plug into our equation. We don't always need to do that, but it's an option. It's an option. So when we do that, that's going to become 6 equals a times negative 2 minus 3 squared plus k. Then we just do a little simplifying. We get 6 equals let's see. Negative 2 minus 3 is going to be negative 5. Square that, we get positive 25. I think we can handle skipping that step. So 25a plus k equals 6. Now this is as far as we can go because we have two different variables. We can't combine like terms because they're not like terms. So we're not going to be able to move any further with that equation. But whenever we have two variables, that just means we need two equations, or that's one way to get around that problem. And look at this. We've got another ordered pair. We've got another x and y we can plug in. So let's plug it in and see what happens. This becomes 1 equals a times x is 3, so it's 3 minus 3 squared plus k. Now we just do a little simplifying. We get 1 equals 3 minus 3 is 0, and 0 squared is still 0, so a times 0 actually goes away. So we're just left with k. That's going to make our lives a lot easier here. We don't have to do any elimination or substitution. Well, I guess we're still going to substitute, but the substitution is going to be a lot easier because we know what k equals. We can just take that and plug it into the blue. That becomes 6 equals, let's write that a little bit better. 6 equals 25 times 1. Oh, excuse me, 25 times a plus 1. Almost plugged 1 in for the wrong variable there. Take away 1 from both sides. We get 5 equals 25a. Divide everything by 25 to get a by itself. And we get 1/5 equals a. I'm just going to leave it as a fraction. So our final answer, a equals 1/5, k equals 1. And we're done with 1. Let's take a look at our objective. Today we're doing chapter 4, section 2. After today we should be able to graph quadratic functions using standard form. So not in vertex form, that's what we did in 4-1, but 4-2, the second section in this chapter, is all about standard form, which hopefully you've seen before, but in case you haven't, this is it right here. Standard form of a quadratic is f of x equals ax squared plus bx plus c. Now, we can read this very similarly to the way we read y equals mx plus b. When we have y equals mx plus b, okay, the m value is our slope, the b is our slope intercept. Excuse me, the b is our y-intercept. So mx plus b gives us a formula to follow to graph a line. This works the exact same way. Ax squared plus bx plus c is a formula we can use to graph a quadratic function. We just have to know what those letters mean and what they're telling us to do when we're graphing it. Now, this right here is probably the most important thing we're going to write down, maybe in this whole chapter. It's definitely the most important thing we're writing down today. Because whenever we have to graph a quadratic, the first thing we should do should always be to find the vertex, because that's the most important point of any quadratic, of any parabola, the vertex. And the x-coordinate of the vertex is going to be negative b over 2a. So whatever our b value is, whatever our a value is, we plug them in to negative b over 2a, and that will give us the x-coordinate of the vertex. And we'll see how that works in a little bit when we get to our examples and actually have some numbers to deal with. Now don't worry, we're not going to forget about c. c is the y-intercept. That's the y-intercept. Now keep in mind, this constant right here, c, will only be the y-intercept if it's in standard form. If it's in vertex form, then what we're adding or subtracting outside is the k value. But since it's in standard form this time, c is the y-intercept. And we'll talk more about why that is on the next slide. Now, here's something that always blows my mind whenever I think about this, because a is the same in vertex form and standard form. So when we have, if we have vertex form, so f of x equals a times x minus h squared plus k, these two a values will always be the same number, which means we can treat them the same way. So just like we use A in 4-1, okay, we've got our vertex. We just go right one and then up or down whatever A is. We get to do that same trick in standard form because A is the same thing. Right? Even though it looks different, or excuse me, even though the rest of the equation or the formula looks different, we can still treat A the exact same way, which makes things a lot easier. All right, on this next slide, let's talk about C, and specifically, why is C the y-intercept? Now, to figure this out, let's think, okay, where are our y-intercepts? Well, the y-intercept is anywhere on the y-axis. Any of those points I just drew could be a y-intercept of a function. Now, we don't know all of those numbers, but for each of those y-intercepts, we should know one number. We should know the x value. The x value of any y-intercept will always be 0, because we don't move left or right from the origin, we only move up or down. So this is another big skill you need to know as we grow in our mathematical careers. Whenever you're finding or trying to find a y-intercept, you can plug in 0 for x. So for g of x, if we wanted to find the y-intercept, it would just be g of 0. So that would be 0 squared minus 5 times 0 plus 3. Well, the 0 squared, that's just 0. The negative 5 times 0, that's just 0. So we end up with g of 0 equaling 3. So 3 is the y-intercept. That was our c value. And we can also use, I didn't want to get rid of all of that. We can also do the same thing in the formula for standard form. Ax squared plus bx plus c right here. We can just take 0 and plug it in. So it becomes a times 0 squared plus b times 0 squared, just b times 0 plus c. And again, that goes away, and we're just left with c. So the reason that c is the y-intercept is because we're not multiplying it with x. There's c is the only one in standard form that's not being multiplied by x. So when we plug in 0 for x, all the other terms disappear and we're left with our c value, our constant. Remember, that's the name of a number that does not have a variable with it. So it's not a coefficient, it's a constant. And because it's a constant and not a coefficient, when we plug in 0 for x, it's sort of the last man standing. The cheese stands alone, as the saying goes. All right, so hopefully that makes sense. Let's jump into an example. Just 2 examples to go through. It says graph a function and fill in the information. Now, if you were looking at this and sort of getting some deja vu, I wouldn't blame you, because a lot of this looks exactly the same as what we did in 4-1. The only difference is now what we have is written in standard form, not vertex form. Now, there are ways to go from standard form to vertex form and then graph it, but I think that's more trouble than it's worth. I think it's better to just be able to deal with the standard form and graph it. All right, so let's think about this. The first thing we need is our vertex, and we start with the x-coordinate of the vertex being negative b over 2a. That's sort of our bread and butter, our sort of cornerstone, our rock for graphing a quadratic in standard form. We always start with negative b over 2a. I'm actually getting a little ahead of ourselves. Let's make sure we all see what a, b, and c are. So the standard form is ax squared plus bx plus c. So then that would tell us, let me slide this down just a little bit to get a little bit more space for our work. That tells us that a equals negative 2, b equals negative 8, and c equals negative 7. If you're good enough that you don't need to write all that down and you can just see it, that's a good thing. I just want to make sure everyone can follow along with the video. Now, we're going to take b and a and substitute them in. So it's negative b divided by 2a. So b is a negative 8, negative b, how do I say this? Negative b means negative 8. So those double negatives come out to a positive. Minus a negative becomes positive. Then 2 times a, that's just 2 times negative 2. And let's see, that's 8 divided by negative 4. So we get negative 2. Okay, so we found a number, but we have to keep track of it. Wait, what was that number going to represent? What does this negative b over 2a get us? Well, it's the x-coordinate of the vertex. So what we just found here, wrong slide, still the wrong slide, what we just found here with this negative 2 is the first part of our vertex. So the vertex is going to be negative 2 something. Hopefully you know this already, but whenever we have an x value, to find the y value that goes along with it, we just take the x and plug it into our function. So that means, let me draw a line here to sort of separate our work because it's getting a little crowded. We just take negative 2 and plug it into the function. So we get y equals -2 times, plug in our x is -2 squared, minus 8 times -2 minus 7. Then we simplify. That becomes, that's -2. I'll show some work here. -2 times +4 plus 16 minus 7 equals, let's see, -2 times 4, that's going to be 8, plus 16 minus 7. Oh, wait, did I miss a negative? I did. That should have been a -8. That was a close call. 16 minus 7, that's 9, if I'm doing that correctly in my head. Yep. So we end up with a y value of +1. So -2, 1 is our vertex. Now we can graph it. Let's go to the graph, go to -2, 1. That's our most important point. That's the vertex. And from here, a lot of the same stuff we did in 4-1 applies. I can put my axis of symmetry right through it. And then we can use our a value to find our next point. Because remember, the a value is the same thing in vertex form and standard form. So since a is -2, we go right 1 from our vertex, and then up or down. Since it's negative, it's going to be down 2. And that puts us right there. So we get a point right there for our a value. Then we can use the axis of symmetry to fold it over and get another point. Now, normally, this is where we would say, okay, so we just plugged in -2, then we plugged in -1, so now we have to plug in 0 and take the number and plug it in. Or we could go the other direction and say, okay, we just did -2, then we have one at -3, we plug in -4. But the beauty of standard form is we don't need to do any of that. We have another point sitting there waiting for us, and it's our c value. That's always the y-intercept. So we know the y-intercept is going to be -7. Just go to -7 on the y-axis, and there we go. Use the axis of symmetry to fold it over, and we've got our parabola. My drawings are never going to be perfect, but it's close enough. It's close enough for us. Now the graph's done. We just have to fill in our information, and hopefully this is stuff we're already good at because we've been doing this a lot so far in this chapter. The axis of symmetry, that will be x equals -2. The max or min, let's see, we have a maximum value here. The maximum value is 1, because that's the y value of the vertex. Concavity, it is concave down, because it's open down, and our a value was negative, so that makes sense. The domain of any quadratic is all reals. And the range, let's see, it's going to be all reals where y is, let's see, it was a maximum, so y is going to be less than or equal to 1. There we go. You can also write those in set notation. It doesn't make a difference. It doesn't make a difference. It's example 1 down. Let's take a look at example 2. If you want to try this one on your own, you can. That's totally cool, but I'm just going to not waste any time and jump right into this. We're going to graph the function and fill in the information. So we see it's in standard form. It's not in vertex form. But even though it's not in vertex form, we still need to find the vertex first. And in standard form, our starting point for the vertex is always -b over 2a, which will be a little weird here. Let's see what happens since we have that fraction in front. But we can deal with that. We can deal with that. So it's -6 for b, so that becomes +6 when we plug it in. And then it's 2 times a, so that's 2 times 3 over 4. Now, there's a few different ways to simplify this. I'm going to show you how I would do it in my head. So I'm going to leave the 6 alone for now, and I'm going to multiply the 2 and the 3 over 4. I'm going to treat the 2 like it's a 2 over 1, and then we can actually cross-cancel the 2's and the 4's and just be left with a 2, and that 2 turns into a 1. So we're left with 6 divided by 3 over 2. But we know that. That's the same thing as 6 divided by 3 over 2. So then we can just, I forget what they call the trick in elementary school, but basically we just multiply by the reciprocal. So that becomes 6 times 2 over 3. And again, we make it 6 over 1. We can cross cancel there. 3 becomes 1, 6 becomes 2, and we're left with 4. Now keep in mind what this 4 represents. The 4 is the x value of the vertex. So it's 4 something. To find that something, we have to take the 4 and plug it in. I'm going to need a little bit more space here. Scroll the coordinate plane down. So let's plug in that x value of 4. So that becomes, let me draw a line here just to show my work, or separate my work. So it's f of 4 equals 3 over 4 times 4 squared. If you can skip some of these steps, that's a good thing. I'm just showing all my work for the video. And then we simplify. So f of 4, that's going to equal, let's see, 4 squared will be 16, and then we can do 16 divided by 4 to make it a little bit easier, and that becomes 4. 3 times 4 is 12, minus 6 times 4 is 24, and plus 9 just comes down. And let's see, 12 take away 24 is negative 12, plus 9 gets us to a negative 3. So that's the y-coordinate of the vertex. Let's go to the graph and graph it, then we'll fill in all the other information. So it's 4, negative 3 for our vertex, 4, negative 3 right there. We can draw our axis of symmetry right through it. Now let's use our a value. So we always go right 1 and up or down whatever a is. A was 3/4 though, so we're sort of going to have to estimate going up 3/4. It's a little bit more than half, and then we can fold it over. It's not going to be perfect, but it's still good to put that point in there to show that you know what the a value actually does to this graph. And then we just use the y-intercept, which is c, which is 9, so 0, 9. And then we fold that over. Let's see, that's 1, 2, 3, 4 steps away from the axis of symmetry. 1, 2, 3, 4 steps on the other side. And we've got our parabola. Now all we have to do is fill in all the information, and we're done. The axis of symmetry, that is, let's put it right here, x equals 4. The max or min is going to be a minimum value, and it's going to be, that was a big jump. The minimum value is negative 3. Concavity, it's concave up, because it's open up, and we have a positive a value, so that all makes sense. The domain is always all reals. This thing is jumping around like crazy. All reals. And the range will be all reals where y is, let's see, it's a minimum value, so that means it's going to be greater than or equal to the y value of negative 3. And we're done. Hopefully that all made sense. If you have any questions, let me know. Enjoy the rest of your day.